Hi everybody, this is Mrs. Logus and I will be taking you through numbers 10 to 17 on this video, maybe 2, which is a lot of trig. So let's get started. Number 10 asks us to evaluate, or to find the exact ratio value. The reason the directions are as such is because if you take a look at A and B, they give you the trig function and they give you an angle. So what we're doing is whenever we're dealing with the unit circle, if we're plugging in an angle, out comes a ratio each time. And this ratio usually comes from a coordinate on the unit circle. But if we look at negative 13 pi over 4 and we look at 930 degrees, both of these are not on the unit circle currently. So what we need to do is consider coterminal angles. So if I looked at negative 13 pi over 4 and I added a full rotation, which in radians is 2 pi all the way around, that would really be negative 13 pi over 4, and with a denominator of 4, that's 8 pi over 4, which would be negative 5 pi over 4. Now that is not quite on the unit circle yet, so we're going to do another rotation. Negative 5 pi over 4 plus another 2 pi, or 8 pi over 4, would be 3 pi over 4. So what this problem is asking is for us to find the secant of 3 pi over 4. So what we could do is two things. You could think about cosine first if you'd like, or you can go directly to secant. But for the case of understanding in this video, I'm going to find the angle 3 pi over 4, which is right here. Secant relates to the x value or relates to cosine. So what we could do is find the cosine of 3 pi over 4 first, and that is a negative root 2 over 2, which means that the secant is the reciprocal of this, which some of you already know is just root 2, but if I'd like to show the work, the secant is really negative 2 over root 2, which, if I bring this work down here, negative 2 over root 2, if rationalized, multiply top and bottom by root 2, is negative 2 root 2 over 2, which is just, in the end, negative root 2. To be faster, some of you might have noticed the pattern that negative root 2 over 2 and root 2 over 1 are reciprocals. So because these are reciprocal functions, you can quickly work backwards without showing all this work. Part B, 930 again is not on the unit circle. So what we can do is keep subtracting this time 360 degrees until we bump into an angle on the unit circle. The reason we added over here is because the angle was super negative to begin. Here the angle is much bigger than the unit circle. So if I do 930 minus 360 degrees, I get 570 degrees. Not on the unit circle yet, so if I do 570 minus 360, we end up with 210, which is on the unit circle, which means this question is actually asking us to find the tangent of 210 degrees. Now, when we look at 210, remember tangent's not given to us directly on the unit circle, so we have to find what the tangent value is there. Again, some of you by now might recognize the tangent values here, here, and here in the first quadrant. This tangent value, if you divide y by x, is always root 3 over 3. This tangent value is 1, and this tangent value is root 3. And again, root 3 over 3 and root 3 are reciprocals, which makes sense because you're looking from different perspectives of a right triangle. Now, some of you might just look at this dot and say it goes with the 30-based angles, and in the third quadrant, the tangent values are positive, so you know this is also root 3 over 3 here. But if you're not sure, show the work. Take your y value, which is negative 1/2, divide that by your x value, which is negative root 3 over 2. That would be negative 1/2 times the reciprocal, negative 2 over root 3. These cross out. Negative times negative is a positive 1 over root 3, which simplifies, if rationalized, to root 3 over 3. So I tried to be very thorough there to work with both students. Some of you can skip right past this because you don't need it. But you either can have these memorized or show the work with y divided by x. Number 11 is asking you to find the exact angles or to find theta between 0 and 2 pi. So again, these directions mean a lot on a test. Not only do the directions say from 0 to 2 pi, which means that I want my answer in radians, It also implies if it has to be between 0 and 2 pi that my answers must be positive angles. And thirdly, it implies that if I'm going around the unit circle once, I'm going to have two answers. So when you see this direction on the test, you need to recognize it's really telling you all of these things in one. So if I looked at part A, I'm asking at what angles are the cosecant values -2? Now we're not as familiar with cosecant, so what we could do again is change our perspective to be sine. So if I looked here, I could say if cosecant equals -2, that means I know that the reciprocal function of sine is equal to -1/2. So now we're asking, at what angles are the y values equal to -1/2? So let's see. If I go around the unit circle, sine is -1/2 here, and it's also -1/2 here. So my two answers would be 7 pi over 6 in radians and 11 pi over 6 in radians. Notice the directions do not ask for degrees. The reason we don't have to deal with the restrictions here is because we're not technically taking an inverse of each side. We're just asking where is this angle, or where is the sine value -1/2. So we're not technically taking an inverse, which is why I'm not considering the restrictions. If I look at part B, again, we have cotangent is undefined. So what that really means to me is I know that cotangent really is something like a number over 0. So that means that if I think the reciprocal logic, I know that tangent, the reciprocal to cotangent, is really equal to 0 over 1. And 0 over 1 is really just 0. So we're asking, where are the tangent values 0 on the unit circle, or at what angles are the tangent values 0? Well, let's see. If I do 0 divided by 1, or y divided by x, it's 0 here. 1 divided by 0 is undefined. That's not true. In this case, 0 divided by -1 is 0, so that's good. Let me change color. So we picked this one so far and this one. The y divided by x here, -1 divided by 0 is undefined. So tangent is only 0, this angle of 0 and this angle of pi. So my answers are 0 and pi. And again, I'm not considering restrictions because I did not take an inverse of both sides. I'm just looking at the unit circle and asking where are these angles true. However, if we look at number 12, it asks, find the exact value of the inverses. Notice, there is no direction from 0 to 2 pi. Whenever you don't see this direction, that means we only want one answer. And whenever you see the phrase arc, that again should mean a few things to you. Arcs mean you're leading to angles, which means you're taking an inverse, which means you have to consider restrictions. So before I start this problem, we're looking for an angle here, and arctan is restricted in quadrants 1 and 4. So we're looking for an angle that the tangent value is -√3. Well, if we go more quickly this time, my tangent value at a 30-based angle is √3 over 3 if I take y divided by x. This divided by this is 1, and y divided by x here is √3. So I know that tangent is negative in quadrants 2 and 4. So the two possible angles, √3 is 60-based, so it would be here or it would be here. Which one of these red dots is within the restriction of 1 and 4? This one. So I'm thinking my angle that the question wants is 5 pi over 3. However, if we are restricted to quadrants 1 and 4, usually when we're finding an angle, we go counterclockwise all the way around to 5 pi over 3. But again, picture this as a wall if we're restricted to 1 and 4. We get to here, and we can't pass this red line. So what we have to do is go backwards to 5 pi over 3 according to the restrictions. And so if I'm going backwards, my angles are negative. So a coterminal angle or an equivalent angle at 5 pi over 3 is really negative pi over 3. That is why the answer in the answer key is negative pi over 3, because of those restrictions. You can also think about that if you're restricted to this side, you have to be between pi over 2 and down here negative pi over 2. And 5 pi over 3 is not between these two values. but negative pi over 3 is between these two values. So if I look at part B here, I paused and I erased the circle here. What we're trying to find is an angle, and arc cosine is restricted to quadrants 1 and 2. So we're trying to find an angle in quadrants 1 and 2 where the x value is negative 1/2. And we generally want one answer here. So if I know I'm restricted to these two quadrants, I'm going to scan, and I notice that the x values are negative 1/2 here at 2 pi over 3. So let's just check our restrictions here. If you're stuck in quadrants 1 and 2, that means you're going from 0 to pi. So in terms of thirds, that means you're going from 0 pi over 3 to 3 pi over 3. Is 2 pi over 3 between 0 pi over 3 and 3 pi over 3? Yes, it is. So my answer is 2 pi over 3, and I do not need to worry about this type of idea over here. Generally, remember that this negative angle thing only really happens when you're restricted in the fourth quadrant. Let's let the good times keep rolling and do composition of functions with the same logic we were just talking about. So we want to find the exact value of each composition, and you always want to start inside out. So if I looked at part A, the first thing we want to do is find the cosine, or the x value, at the angle of 5 pi over 4, which is right here. So the x value there is negative root 2 over 2, so I can replace this completely with negative root 2 over 2. But I'm still trying to find the arcsine, or the angle, that the y value is negative root 2 over 2. Now arcsine is restricted to quadrants 1 and 4, so we're looking here and here. So where in these two quadrants is the y value negative root 2 over 2? Well, it's true at 7 pi over 4. However, like the last page, if we're restricted to these two quadrants, we have to go this direction. So instead of 7 pi over 4, the answer will be negative pi over 4 to be within the restrictions. If I look at part B, we need to find the tangent of 3 pi over 4 first. So we're looking here. The tangent value at pi over 4 is 1. So the tangent value in the second quadrant will be negative 1, because you're taking y divided by x. So all of this can be replaced with negative 1. And now we're trying to find the arc cosine, or we're trying to find the angle arc. And our cosine is restricted to quadrants 1 and 2 this time, so up here, where the cosine value is negative 1, or the x value is negative 1. There's only one place where that's true, right there at pi. And pi is within our first and second quadrant, I would say, so we're good to go with our answer as the angle of pi. Part C is asking to first find the arc cosine of negative root 3 over 2. So that means I want to find an angle, again, restricted to quadrants 1 and 2, where the x value is negative root 3 over 2. So if I draw this line so I know it's restricted, I look for the x value of negative root 3 over 2. That's here at 5 pi over 6. So my angle within the restrictions is 5 pi over 6. But now I want to find the cosecant value at 5 pi over 6. So what we could do first is find the reciprocal value. Sine of 5 pi over 6 is 1/2, which means the cosecant is the reciprocal of 2 over 1, or just 2. And lastly, in this section, and we'll probably have to move to another video in just a bit, we want to find the secant of the arctangent of negative 1. Well, the angle here is restricted to quadrants 1 and 4. So we want to find where the tangent value is negative 1. If it's positive 1 here, the tangent value is negative 1 here. So we're finding the secant of 7 pi over 4. Technically, with restrictions, you're finding the secant of negative pi over 4, but these are the same. So if I wanted to find the secant value, I could first find the cosine of 7 pi over 4. The x value is root 2 over 2. but the reciprocal of root 2 over 2 is just root 2.